This is a quick, hopefully refresher lesson on solving one-step equations or formulas. So as you should know, an equation is something that looks like this, 3m equals 12. It's called an equation because both sides are equal to each other, so it's balanced. What we need to do here is determine what m is equal to in this equation. M is called the variable, and that means it's the quantity that can change. So you need to isolate m by doing a little bit of math on each side of the equation so that it's by itself, so that you know what it then equals. So you have to think about what is happening to m right now, and in this case 3m means that 3 is being multiplied by m. So you're going to need to do the inverse operation or the opposite operation in order to isolate m by itself. So for now, 3 times m, if we divide both sides by 3, because whatever you do to the one side, you must do to the other side. Divide both sides by 3, so we have m times 3 divided by 3 over here, so our 3's cancel out. So we have m is equal to 12 over 3, which is 4. So these are one-step equations, meaning that there's generally just one thing that you have to do to each side to get your answer. So we know that m, now the variable, is equal to 4. We can check our answer by subbing our answer back into the original equation. So we go 3 times 4 in brackets equals 12, and then you solve, and you have 12 equals 12, which means that we've obviously done this correctly. If you ended up with something that was not equal, so some other number equals 12, you would know that your answer is wrong. Okay, so our second equation, y plus 3 equals 12. Alright, so right now we have 3 is being added to y. So what we need to do on both sides of the equations is subtract 3, because subtraction is the opposite of addition. So y plus 3 minus 3 is equal to 12 minus 3. Remember, whatever you do to this side, you have to do to the other side as well. So if we have plus 3 minus 3 over here, we just have that y is equal to 12 minus 3, which is 9. And of course, always check your work, sub your answer, substitute it back into your original equation so that you have 9 plus 3 equals 12. And just like the first time, 12 is equal to 12, so this has been done correctly. You may have also seen checks done like this, where you have left side, right side, and then you sub in 9 plus 3, 12, and then 12 here, and then you realize they're both the same. Either way is fine as long as you are checking your work every question. Okay, so remember that the opposite of adding is subtracting, and vice versa, and the opposite of multiplying is dividing. That will generally get you through all the questions that you are going to work on today. So let's go through a couple of examples where we have fractions in our equation. So our first one, w over 3, or w divided by 3, is equal to 12. Since w is being divided by 3, we're going to multiply by 3 on both sides. These 3's will cancel out because we're multiplying and dividing by 3, so we're left with w on this side is equal to 12 times 3, which is 36. And of course we can check. I'm going to do a left side, right side check. So over here we had w over 3, over here we had 12. We determined that w is 36. Whoops, 36 divided by 3, and then on your next line here you would have 12 is equal to 12, and that would be correct. So basically what we did here is we multiplied both sides of the equation by the denominator when it's a situation like this. In our next example, we have 1 over 4 times s is equal to negative 3. So again, we're going to multiply both sides by the denominator. So times 4 over here, times 4 over here. These 4's will then cancel out. 1s is all that's left on this side, which is the same thing as just s, is equal to negative 12 on this side. Because 3 times 4, negative 3 times 4 is negative 12. So s is equal to negative 12. Once again, you can perform a check. So over here, we would have 1 over 4 let's try that again. 1 over 4 times negative 12 is equal to negative 3. 1 times negative 12 is negative 12, divided by 4 is negative 3, equals negative 3. So that math has been done correctly. Next example has another fraction in the equation. So we're going to multiply by the denominator again on both sides of our equation. It's going to cancel it on this side. So we'll have 3k is equal to 24. Now k is being multiplied by 3, so we'll divide by 3 on both sides, and we'll be left with k equals 8. Okay? The other way that you could do this one, if you want to do this in one step, is multiply by the inverse fraction, which means that you multiply by 4 over 3 on both sides of your equation. This makes it only a one-step problem instead of separating it into two. Both 3's will cancel out over here, and the 4's, and we'll be left with k equals 6 times 4, which is 24, divided by 3, which is 8, and we get the same answer both ways. Obviously a good sign. And you can also perform a check here. 3 over 4 times 8. Original equation should equal 6. 3 times 8 is 24, divided by 4 is 6, so we have 6 is equal to 6. So we've done that correctly. The last example is actually a formula. This is a type of equation where you just have variables that you're working with. So, for example here, maybe we want to isolate and solve for y. What does y equal? Well, you just look at exactly what's happening in the equations with numbers. Y is being multiplied by x, so we're going to divide both sides by x to isolate y. So we'll have y equals z over x. Same thing if we wanted to isolate x, divide both sides by y, and you would have x equals z over y. So you can do this same process whether you have numbers or just variables or a combination of both. Make sure every single time you check your work though.